Thanks for the introduction. Hi, everyone. As you probably heard, my name is Aaron, and I'm a rising sophomore at Harvard. But right now, probably like most of you, I'm at home in Las Vegas under quarantine. Yeah, thank you for inviting me on to do this talk. I'm very, very excited. But yeah, anyway, I'll get right into it. I'm here to talk to you guys today a little bit about the growing influence of computer science in STEM fields. Not only mathematics, but it's hard to think of a STEM field today that doesn't have some influence from computer science. A little bit of background about myself. When I was in high school, I was a really, really big math student. I did a lot of math competitions. For those of you who are middle school or high school, or maybe have kids who are middle school or high school, you've probably heard of a couple of them, like math counts and AMCs. And I really, really enjoyed those. And when I went to college, I was really, really certain that I wanted to study mathematics in some capacity. But when I got there, I realized that the mathematics, that my impression of mathematics wasn't exactly what it was really like in the field. In fact, it's not exactly the pen and paper calculation that you're usually doing in school. A lot of it is based around computer science. It's the research, the work, almost all of it is done in programming. I think one of the best examples of this right now, a really, really relevant example is with COVID-19 and the type of work that's going in towards modeling it and trying to control the spread. So today I wanted to share with you guys a little bit of the work I did in my first year of college. So I created a program that simulates the spread of infectious diseases like COVID-19. Allows you to kind of play around with the environment and different parameters that can affect the spread. So I'm going to go ahead and share my screen here. So this is essentially a simulation of how an infectious disease would spread in the community where there wasn't much distancing or anything going on. So each of these dots represents a different person or individual, and the color represents kind of what state they're in. So for example, red would represent a person who's infected with the disease and can transmit it to others. Blue would be people who are susceptible, who can get infected by the disease. The darker gray, that's people who have contracted the illness but recovered. And the reason they're not the same as that blue population, the susceptible population, is because for a lot of these diseases, after you contract them, there's a period of immunity afterwards where you have antibodies that make you resistant to the disease. And the lighter gray is the population that is deceased. So you can see here that this is a model of how a disease like COVID-19 would spread in the community, where you have the red representing the amount of cases and whatnot. We can see that there's a pretty drastic amount of cases and deaths, right? We can do this in like a fraction of a second, right? We don't have to write mathematical equations that'll predict the rate of spread. We can just make a program, and we can also change the parameters of the program in a second, just to see how different inputs and different parameters would affect the rate of a spread in the community. So I'm going to show you guys a little bit of the stuff going on in the background here. So this is one of the files that runs the simulation. And these are the parameters that go into it. So for example, we have like the size of the community with the various dimensions. And we also have the initial population, things like that. We have the transmissivity of the disease, the mortality rate, things like that. And what we can do is we can actually alter some of these parameters to see how certain changes in the community can affect how the disease would spread. So one of the things a lot of people have been discussing initially was the idea of social distancing, right? Staying 6 feet apart, quarantining and stuff like that. So we can kind of mimic this idea of social distancing by changing changing a parameter of the program, and we can see how the community and how the spread of the disease would change if we implemented social distancing. And this is pretty similar to how they do it. A lot of researchers do it when they're trying to see how the diseases will spread in those communities. So this is called neighbor radius. It's the distance in which a block of an infected person in the simulation can infect others. And we can kind of simulate the idea of social distancing by decreasing the neighbor radius, meaning that essentially people are less likely to come in contact with one another, which is essentially what social distancing does. So if we're just going to decrease this by 1, right? We're going to change it from 4 to 3. I want to show you that, and we can see that the impact this will have. So I'm going to go ahead, change that, and I'm going to recompile the program and run it one more time. So you can see the program's running again, and we already see a much lower rate of infection in comparison to the previous program, just with a minute amount of social distancing. And it's information like this that we can change changing by changing a number in a program that can tell us so much information about how these policies will impact, how these public health policies will impact, the actual communities that we live in. And this is just with a small, minute change, and we already see this drastic the flattening of the curve that a lot of people talk about. And we see that the number of infections is much, much lower. We see that the spread is much more controlled, right? And this is stuff that normally, if you did it on pencil and paper, could take days, not weeks of time. But we're able to do this using computer science, just by changing a number, right? It's so quick, it's so simple, it takes a fraction of a second. It's really, really nice. It's visualized for you to see. It's really easy to understand. And this is how most of the research, especially when it comes to applied mathematics, maybe with the exception of theoretical mathematics, is done in these STEM fields. A lot of it is based around these computer science programs. Another thing we can do with this program is we can also maybe mimic the idea of wearing a mask, which has been a very hot topic of conversation recently. So again, we're going to go into the parameters of the program, back into this config file, and we can do something to kind of mimic the idea of people wearing a mask. So we can see here, there's a parameter for this program called the infectiousness of the infected people. So that's basically just the chance that someone infected will give somebody else the disease. And a lot of research shows that if you wear a mask, you can reduce this infection. You can reduce the infectiousness of a disease. So we're going to go ahead and change this number from about 0.4 to 0.1, which is actually a very high estimate for the infectiousness of the disease if everyone's wearing a mask. But just for the sake of the simulation, we're going to do it like this. So again, I'm going to recompile the program. We're going to run it again. Here you can see that the rate of infection is much, much, much lower, right? You see the red representing the number of cases there are. And in fact, about just a little bit into the simulation, we can see that there's actually not even any infections left in the community. I mean, will it be completely representative of exactly what's going on in communities? No, but it gives us a good idea of what kind of effect these different policies can have in our communities. It's not an exact representation, but it can tell us a lot about what we can expect when we do implement these policies. And again, this is stuff that happens all within a fraction of a second. The program is running very, very quickly. We don't have there's a lot of mathematics going on in the background, random number generators, but that's not stuff we're doing on pencil and paper. It's all running within the computer. And this is very, very indicative of how a lot of research is going on. So you can see that these programs really enable researchers to do things extremely, extremely quickly. What once took us weeks to do, we can do it almost instantaneously. So now I want to show you guys another thing I've been working on recently. It also kind of shows how much computer science has changed the research field. So recently I've been working as an intern at NASA's Jet Propulsion Laboratory. I've been working with one of the researchers there to take information from molecular clouds and see what it tells us about how stars form in our universe. So we can kind of learn about these molecular clouds that are far out in space by looking through spectroscopy, which essentially tells us about what chemicals and what molecules and what elements make up these clouds. And I want to show you guys one of the data sets that kind of comes from spectroscopy and how, and from the spectrometer and how complex it is. So let me just open it real quick. So yeah, so this is one of the files that we do, one of the data files that we get when we get data from spectrometers. We're looking at these far, far molecular clouds that are millions and millions of light years away. You can see that there's a lot of data, right? I'm scrolling down here, and the scroll bar is barely moving on the side. This is hundreds and thousands of lines of data, right? Just tons and tons and tons of data, right? And you can think if you didn't have, if we had to do this by hand, we had to analyze this by hand, like normal mathematics, how long would this take? We have to parse the data, look through it, plot the points by hand. It would take an insane amount of time, right? But thankfully we have computer science, right? So I've been actually working on a program to go through this spectroscopy data and take certain parts of it that are relevant to us and wrap it into a form that's really easy to understand. So again, we can look at, I'm going to show you guys just a quick little view of the file here. So this is the program that I've been working on as during my internship. And it's essentially a program that takes this very, very ugly, well, not ugly, but very, very convoluted and massive amount of data and converts it into a nice plot that's really easy to understand and really easy to analyze. So I'll go ahead and show you guys what that looks like. So it takes this massive amount of data and it can just turn it into this, which is a nice, for those who know, Gaussian distribution that just shows the total amount of energy and total amount of, right, this is actually the spectral line for oxygen for this cloud. You can see that it's much more easy to understand. It takes seconds, right? I just did it on my computer by inputting a line of code. It runs the program and it gives us this beautiful, beautiful output, right? And it's something that it's so quick, it's very, very simple, it's very, very easy, right? But that's kind of the point I wanted to make about the main point I wanted to make about this presentation about during today's webinar is that computer science has really, really enabled us to take the work in these STEM fields and make it very, very simple and very, very quick and very, very easy. And there's almost no STEM field today out here that hasn't been reached by computer science. Almost all the research you can imagine that's being done out there is being conducted using computers and using these programs. And a lot of times and computer science is something that's not really taught as frequently in schools, and I think it's a pretty big shortcoming in our current school system that we're not teaching as much computer science. I think about 2/3 of all new jobs in STEM are based in computing. It's really, really astounding. Yeah, that's the kind of the main takeaway of today's webinar. But yeah, that's kind of all I really wanted to show you guys today. But I'd be happy to answer any questions you guys have or any comments.
Hi, Aaron. It's Mr. Hill.
Oh, hey, Mr. Hill. How are you?
Good. I saw Sherry and Tiffany were on there too. I don't know if I have any other students on there, but yeah, I think your class left ahead of when we started doing Python in science class at Hyde Park. But I think in Sherry's case, I'm pretty sure she was there when we started doing it. And I sort of recognized that all the new discoveries in science are going to come about by computers, whether it be machine learning, AI. There's just so much opportunity, and it really struck me as a weakness. So we end up with several weeks of Python. I let them use Python for their tests instead of a calculator, because school is so artificial with, like, here, learn how to use this TI calculator that no one in the real world uses anymore. So really glad to hear it and kind of support. Sorry that you missed out on that. I think you're just a year or two ahead of that. So it's really cool. But
yeah, I was able to be part of that. That's awesome. Yeah.
As long as I have you, do you know Sean Reddy?
Yeah, I do.
He's a couple years ahead of you. I think he's doing a similar thing at Stanford on it's called applied mathematics. So it's like a mathematics to solve the world's problems. So kind of a wild thing to see two people doing that.
Yeah, it's a very popular major nowadays. I think it's a lot of the schools are doing like a combination of applied math with computer science. The two are so intertwined with each other, and it's really, really emerging field.
Have you used one other question? Have you used MATLAB at all?
Yeah, I actually used MATLAB my whole year during my mathematics course. So I had 2 like mathematics courses, and half of the problem sets they were doing were MATLAB questions. So I think in high school I took a couple CS courses. I took like APCS, but to see the amount of CS that's going on like in college and doing this research, I think it's really astounding. I think like half of my problems in my math class were all based in programming, which is just fun and also very exciting.
All right, very good. Thank you.
Nice to see you, Mr. Hill. I think I saw a question in the chat.
Yeah. Yeah. Do you think the focus for computer science classes in K through 12 should focus on coding?
It's an interesting question. I think that a lot of coding is really important. I think, obviously, I think it's important to know some like basic concepts of coding. Obviously, maybe computer science isn't for everybody, but I think it's really important to not only teach the kids the coding aspect of computer science, like how to write basic programs, but also just to understand what tasks computer science can accomplish, right? Computer science is, while it can handle a lot of different tasks, it can make a lot of things easier. Obviously, it can't solve everything, right? Computers can only really do what you want it to do, what you tell it to do, and there's some things that computer science can't really solve, right? But there are a lot of problems that a lot of problems that computer science is really meant to tackle, right? Taking these processes that may take a lot of time to do in my hand, but it can be done repetitively and turning them into programs. So while I do think coding is a very important aspect of it, and probably the main aspect that should be taught, I think another very, very important component is teaching students what kind of problems computers are meant to tackle.
Does computer science mean coding?
No, not necessarily. Computer science, while a lot of it is coding, a lot of it, or learning computer science is learning how to code, learning how to create these programs. A lot of theoretical computer science really doesn't involve a lot of coding. A lot of classes, I guess, that I've taken have been based in kind of like learning how to code, but there's also a lot of classes out there that kind of push the boundaries of what computers can do, right? Some of these computer science classes, Harvard specifically, don't even involve any coding. You won't even need a computer the whole semester. And those are courses that teach you about things like algorithms and data structures. And those are kind of teach you about the fundamentals behind how computers work and how they handle the data and how they process the data and how they actually run the programs. And those classes are kind of almost entirely based in mathematics, right? It's learning how to optimize these equations that are running in the background, because computer science, when it kind of boils down to, we can kind of get down to the meat of it, it's really, really just mathematics, right? It's a bunch of 0 and 1, it's binary, and a lot of those optimizations and how exactly you turn this concept into like a computing device is based in math. And so computer science doesn't necessarily mean coding. A lot of it does have to do with coding, but a lot of it is also on the theory side and learning how computers work and learning how we can make computers better and kind of pushing the horizon when it comes to what computers can accomplish.
Can we somehow use your program to show students of how to apply math in real life situation? In a real life situation? I'll reread it. Can we in some way use your program to show students of how to apply math in real life situations?
Like utilize the program I wrote, or I'm just a little confused on what exactly this question is asking. But yeah, I would be more than happy to, like, if you wanted to use it. I don't exactly understand the question, but if you could rephrase or maybe clarify, I would love to answer. Oh yeah, of course. I actually, yeah, I actually have a video on YouTube. It's unlisted, but I could share it with you guys, where I actually like a short little demonstration of how the program worked and how it could reflect how exactly like policies are being implemented when it comes to COVID-19. And I'd be more than happy to share that video, or also just give you access to the program and show you how to run it, so you could show students how exactly math applies to these real life scenarios. sorry, I keep looking at two screens. I have like two desktops, so pictures on one.
Aaron, which high school did you go to, by the way? Any suggestions in terms of STEM classes / competitions to take / join for a rising ninth grader in high school?
Yeah, so I went to Clark High School, and I was part of the MSAT program, which is like Academy of Math, Science, and Technology, which is like a magnet program. Um, I guess suggestions. I don't think I have any like specific suggestions. It really depends on what personally you're interested in. I guess a couple. I guess I get a couple extracurriculars that were pretty. I found very fun and very meaningful during my high school experience in high school, like Science Olympiad and like math counts or math clubs, or not math counts because that's a middle school competition, but like AMCs and those I found really interesting. Specifically Science Olympiad, I did a lot of that. And I like Science Olympiad a lot because even if you don't know like what specifically you're interested in, there's a lot of different individual events within Science Olympiad that all cover different topics. So if you're generally interested in science, it's a really great opportunity to get to explore a certain field or discipline deeper. I guess classes too is just um, I, I really couldn't give you any specific recommendations without really knowing your interests, but yeah.
Did you try to send your simulation results to a mobile phone with a dashboard type format?
Oh, does that mean kind of like converting the simulation to like a mobile app, or like showing the results, or I did not try to do that. It's all still on my computer, just running it using Mac terminal. So, but that would be very interesting. I think it would be a pretty cool format that people could play around with, or just look at the data.
How can a high schooler get involved in computer science or coding?
It's a great question. So obviously, there's kind of the initial idea of you can take computer science classes at your high school or whatever school you go to. Um, but the great thing about computer science is that you don't need to take it. Like all the information that you need is out there online. There's dozens and dozens of websites out there, like CodeHS, Code Academy, Free Code Camp, that all teach CS for free, and you can learn any language you want. I think there are extents to how far you can get, but the great thing about CS is that it's not limited anyway. There's no really barriers to learning it. If you have a computer and internet access, it's really easy to get started. Maybe start with choose a language that you're interested in, maybe Python, maybe Java, maybe C++, and learn from there. And you can, a lot of times, I think the best way is just kind of think of projects that you think are interesting, and try to tackle them on your own. I mean, there's a lot of debugging, a lot of frustration trying to figure it out on your own, but there's a lot of satisfaction in eventually getting it, and it's a lot of self-driven learning that really teaches you not only computer science, but really great like problem solving and critical thinking.
Is the coding club competition at Clark recommended?
I don't. I was not part of that. I might have heard of that. It sounds familiar, but I do not know much about it. I know I think it's if it's the mentor for that is probably Mr. Smedley, because he's the computer science teacher at Clark, and he's a really great teacher. I had him for APCS. I really enjoyed his class. So if he's mentoring it, I would say go for it, because he's a great teacher, and I think it'd be a good experience.
Why do you like mathematics?
I really like math because I think math is essentially the foundation for everything. As much as a lot of fields of science are interesting, and a lot of different other disciplines are very interesting. I love mathematics because everything really boils into math, and it feels like math can solve a lot of problems. And I think if you know math and you know how to do math well, and you know how you understand it well, I think there's really no limit to what you can kind of accomplish and what you can do. I think that the applications of it are really endless.
And I'm not sure if this is a question or a suggestion, or maybe it was for one of the other students, but check out the Congressional App Challenge for a coding competition.
All right, I will check that out.
Okay.
Yeah, we have students do the Congressional App Challenge every year, and it is good. You have to develop an app and stuff. They don't get as much help as they promised. Their congressional staff is supposed to come and help you, but they like never show up because they get busy because the competition is due right at election time, right? So that's been kind of a fail. I had a question though, Aaron, about your model. Have you so you can get all the data from Johns Hopkins online. Have you tried to, and it's frustrating to me because you can see that different countries report this data differently, but have you tried to take, say, the United States and simulate the death rate, the et cetera, that what parameters it are? Because people were, confused as to the transmissibility of the disease and things like that, how many people infect each person and stuff. And it seems like you could kind of use your model and try to match up the data that Johns Hopkins has, and then back calculate that transmissibility factor and things like that. Have you thought about that or done that?
Yeah, I've actually been playing around. I didn't use the Johns Hopkins data, but I was using the data from the World Health Organization, and I wasn't really looking so much at the transmissivity. I was kind of looking at just the trends of the disease. So I was using a machine learning model in R, which is a programming language, just to see where what kind of trajectory we're on with current measures and how the different policies were affecting the transmissivity. But I haven't applied it to the simulation, but I think that would be very, very interesting. I think that would be great. I might try that, yeah, because I think that I haven't really tailored the numbers of the simulation completely to mimic COVID-19. The numbers are a little bit off. They're not exactly scalable, especially since we don't know too much about the transmissivity and the mortality rate. It's kind of like a ballpark estimate right now.
It'd be really cool because you could compare Australia and New Zealand or other countries that have been pretty successful with countries that have not been successful, and how also it comes back so strong. It'd be kind of interesting.
Yeah, I will definitely agree to that.
When is it a good time to start learning computer science, or a good age?
I think a good time. I think there's I mean, obviously not when not too young, obviously, but I don't think there's really a limit on when you can start learning computer science. As much as confusing as computer science can seem sometimes with all the stuff and the code on the screen, a lot of it boils down to basic logic. It's kind of as simple as, it's almost as logical as mathematics is. I don't really think there's necessarily an age that's limits when you can learn computer science. I think even elementary school, maybe third, fourth, fifth grade, I think those are all great times to maybe start learning how to do some basic coding in middle school, high school, whenever. I personally didn't start learning how to code until probably maybe junior year of high school. But I did a lot of math, and it's really, really helpful when it comes to thinking logically, mathematically. I think it's learning how to critically think about problems. So I don't think there's a limit on when to start learning, but I think any age where once you can start, learning mathematics and sciences, I think that's a great age to start learning how to code too.
Any more questions?
I have one. This is Diana Strictly. I'm sorry I'm not on camera today. With the COVID-19 outbreak, I remember when the White House would do their briefings, they would show the different models. And a lot of people just kind of took those as set in stone and didn't really understand, okay, well, we're gonna redo the model base because the parameters changed. And I'm wondering if you had thought of, because you explained how your model works and how you change things going into it and pointed out now we can see. Have you ever thought of doing some YouTube videos that might help more people understand the models that they see or get referred to on the news?
I think that would be a great idea. I think a lot of people kind of look at the models and assume this is exactly what's going to happen, and maybe they're a little bit frustrated when they see oh, this is not actually how it played out, right? Or maybe when they see that the estimates or the range of potential outcomes is so huge. And it's hard to understand that. I think that would be very, very helpful because it really helps to look through the actual models and understand the models, to understand there's so many different parameters, especially when you have, and this is just a small simulation in a small community, but when you're looking at an entire country where there's thousands of different communities that all have different policies and all have different measures in place, it's really, really difficult to give an accurate estimates or really understand the models that are going into it that are a lot more complex. So yeah, I think that would be a great idea. Definitely going into how these models actually work and why they can be so volatile sometimes.
So I guess the next challenge on that would be is how you communicate that, but still have not lose the message that you can have faith in the model. You know, that all models are wrong, but models are useful.
Yeah.
Have you heard that? Like they kept throwing that around. I think a lot of people just don't really understand that you can have faith in a model, but you have to understand the limitations of the model. And I think watching you actually go through and tweak values that you're putting in and show the different results, like kind of helps that, along with the caveats that you put in about, okay, well, this won't be perfect or this won't be really realistic, but I just want to show you like what happens when you put in a different number. So anyway, I'm just kind of putting that out there because like that was one of the things that I run into with people a lot, is they just don't really understand what's going into those models when all they see is the final product.
Yeah, I think it's a great recommendation. I definitely agree with that. I think that showing people the actual things, parameters are going in, and showing how it changes is definitely going to help them understand it, how it's working better.
What are you actually doing as an intern at JPL?
Well, I thought that's what I was doing, but what I'm doing is we have like spectrometers on satellites that can get information about molecular clouds, can tell us about the chemical composition of these clouds, and so what I'm doing is I'm taking the data that's coming in from these, and I'm writing programs to correlate the chemical composition of these clouds and see what it tells us about the stars that form there, how stars form there, the other physical properties of the clouds. I guess a more niche thing that I'm doing is there's a couple issues within spectroscopy right now that lead to some issues in the data. That kind of, there's like I could show actually it's a little difficult, but there's essentially some issues in spectroscopy data right now. Some caused by like foreground absorption when we're doing spectrometer readings, and I'm running a program as well to kind of solve that issue.
Aaron, do you mind sharing some of your other interests in middle school and high school? Thanks.
Yeah, as I said, I was a big math counts guy. I did Science Olympiad a lot. I did Mr. Hill as my coach actually, and then I did it in high school as well. And those were kind of the math competitions and Science Olympiad were the two kind of big things that I did during high school and middle school outside of classes. But I also did a lot of things kind of outside of school. I did some scientific, like over the summers, I would do some science research at different camps or different laboratories. And I also was pretty involved in like if you've heard of it, like the Las Vegas Math Circle. So we do a lot of organizing of like camps, and we also go to like some high school collegiate competitions. Like if you heard of them, like HMMT, which is Harvard MIT Mathematics Tournament, and PUMAC, which is Princeton's. I did a couple of those, and then towards the later half of my high school career, I started doing some more things like independently, and a lot of that started when I started doing more computer science work. So I did a couple of projects at home, just some things that I was curious about or interested in that I thought I could maybe recreate or play around with on a computer. Harvard.
Will Harvard go online in the coming fall?
Yeah, so Harvard announced a couple days ago that we're going to be, classes probably for the whole academic school year are going to be virtual. Um, uh, so I will be doing classes most likely online, or maybe taking a gap year. Haven't come to a concrete solution. There's our decision on that yet. I know that they are, however, allowing freshmen like Sherry to go back on campus in the fall. I'm a little bit jealous. And then seniors to go back in spring. So I'm a sophomore, and also the juniors will not be most likely not be able to go back to campus unless they have other extenuating circumstances. So yeah, it will be on that.
Can someone succeed in computer science if they are not great at math?
Yeah, of course. I think that's one of the great things about that's one of the great things that comes out of computer science. The fact that it kind of does the math for you, right? Which is really, really nice. I think that it's important to have good logical understanding, though, when it comes to computer science. And I don't think that, I think that's something that kind of improves as you write more and more programs, because one of the things you learn once you start kind of taking computer science courses is that it's not that hard to write a program, but it's really, really hard to write a good program, right? Because there's so many ways to accomplish a certain task, but a lot of it comes down to optimizing the task and how to make it as efficient as possible. I guess that's more so a thing. While that's important in STEM fields as well, I think that's more so a thing when it comes to industry computer science, when they're trying to optimize like web page loading times, because 0.01 seconds extra on a web page loading time could be like a revenue loss of millions of dollars a year. So yeah, but I don't think it's that necessary to be good at math, because it's really doing most of it for you. But I definitely think that the logic half of computer science will really help you improve math as well.
What is your most difficult challenge in Harvard?
Most difficult challenge at Harvard. I think one of the most difficult things is definitely just how drastically the course load changes when you go from high school to college. I think the type of material learning, the way you learn it, the independence of it is all very is all not only difficult, not necessarily difficult. It is difficult, but it's also very fulfilling. I think it's you get to learn things that you have particular interest in. The content is very interesting, while self-driven. I think it's really, really interesting stuff that usually keeps you pretty encapsulated, pretty on track. But yeah, I think that the most difficult part is definitely just getting used to that independent learning, independent lifestyle. For me, at least.
Which program should a high schooler learn first?
I guess this would be like programming language. I guess personally, I would recommend a language like Python, maybe, because it's more of a higher level programming language that the coding for it is more similar to the way that we think. So some languages are a more lower level where it's a little more difficult to kind of write the code, but I think Python maybe is a good place to start. That was like one of the first languages I learned personally. I learned well. I think it's a really good starting point. It's also, I think, right now is the most popular programming language out there. So, and it can accomplish a wide variety of things.
How did you find your niche or niches where you chose to apply your CS plus math knowledge?
Well, as much as I would like to say that I found my niche, like I've really been all over the place when it comes to working on my CS and kind of applying it. I've like been exploring kind of my first year on a lot of different subject areas. Some of them have been less interesting to me. Some of them have been more interesting to me. But I think for you specifically, Sherry, when you do get there, there's so many opportunities, and I say kind of go for them, and then just see which ones you enjoyed. I think it's a lot of that happens in your first year, because you kind of do a lot of different things, and then kind of from there you have which one do I like the most, which one do I want to continue with, which ones do I want to stop, and then that's kind of where I am right now. I've kind of found like which ones I enjoyed, and those are the ones I'm going to continue doing as I progress in my education.
So will you be staying at home in the coming fall?
I haven't really come to a decision yet. Some of my friends and I, who were gonna like room together at Harvard, we were thinking about maybe renting an apartment somewhere so we could do like the courses together. Um, so there's a good chance I won't be at home, but you never know. So.
How did you get the JPL internship?
So I was just looking for internships as a freshman, and I was kind of emailing just all over the place because as a freshman, it's just more difficult to find internships in general. I mean, JPL, I've always wanted to work at NASA or see what working at NASA would be like. So JPL and a couple other laboratories, NASA laboratories were a lot of places that I was emailing, and I was just emailing and asking if I could work there over the summer, and I was lucky enough to get a yes from one of my mentor at JPL. So.
How do you like Harvard going online for not only coming fall but next year maybe? Do you
I think I understand the question. Just like, what do I think about Harvard going online for like the whole year? But as much as I would love to go back to campus and live with my friends, take courses in person, I understand that students going back to campus is a public health concern. So I respect the decision that Harvard made. And I know it's unfortunate, but my plan, to be completely honest, I'm not entirely sure of my plan yet. I'm considering maybe taking a gap year, but I'm not entirely sure what I would be doing. Maybe I'd look into a couple opportunities. Yeah, I would either be taking courses online for the whole year, or I would be maybe doing a potential remote internship or during a gap year.
any particular challenges for high school students from Nevada to go to Harvard or elite universities in general on the coast?
Not necessarily think there are any challenges that are specific to our state or like our region. I think a lot of it just comes down to it's really on an individual level, but I don't think there are any particular challenges. I think a lot of it, however, is obviously like it's luck as well. Like it's a pretty random thing, but I do think that if you work hard and you do what you think, if you kind of exceed at what you're really passionate about and you convey that when you are applying to these universities, I think that you can really increase your chances of admission.
What's the most creative thing you've ever done in your life?
That is quite the question. Most creative thing I've ever done in my life. That painting over there is pretty creative. It's a difficult question. I think probably the most creative thing I've done was in high school. Uh, I kind of noticed that like when we had like fire drills or I guess it's kind of a story, but when we had like fire drills or like an emergency lockdowns, the system that we had to like communicate it and like communicate with like within the school was just very, very ineffective. So during my free time, I was working on like a small application to streamline that process. So that's probably the most creative thing I've done.
Mathematicians always like mathematics. Is being creative, right? Always say like mathematics is creative, right?
Yeah, I mean, I haven't heard that specifically anywhere, but I don't disagree with this statement at all. I think that being creative is an important part of mathematics. As much as it's founded in logic and intuition, I think that um, a lot of the really great applications and a lot of the really great discoveries in mathematics come out of creative thinking. And yeah, I agree. I think creativity is a very, very not just mathematics, but almost anything you do. I think it's very important.
What's the difference between math and applied math?
So yeah, I guess one of the big distinctions in mathematics is applied mathematics versus theoretical mathematics, which I'm assuming is the kind of the meaning behind the word teaching math. So theoretical mathematics is kind of like down or like investigating the fundamentals of math. So like discovering new theorems, working on like very, very challenging problems, kind of pushing the boundaries of what we know about math. So that's kind of stuff that's kind of, when you think about the traditional like professor like working on a problem on a chalkboard kind of thing, I guess. And applied mathematics is more of applying these mathematical concepts that already exist to different fields. So, for example, like I guess a lot of different sciences or engineering kind of disciplines we thought of as like an applied math discipline, since a lot of the stuff going into is mathematical principles. So, applied math is basically taking your mathematical knowledge and using it to solve problems in fields that aren't math or just other fields, other disciplines.
I assume applied math is within engineering school of Harvard behind the Science Center.
Yeah, I think it is in the engineering school. Uh, I don't think the applied math like offices we're referring to is not necessarily behind the Science Center, but I think the AM department at Harvard is encapsulated by the engineering, or they're combined into one department because they're so intertwined.
What would Aaron and some of the teachers in the group consider to be top college preparatory high schools in Las Vegas? Public, private, or charter?
I think a lot of good schools. I mean, I only went to one school in Vegas. I went to Clark High School, so I couldn't really speak that much for other schools. A couple of schools I heard about a lot, I guess, other than Clark, are like A Tech, West Tech, Rancho High School, but Green Valley High School, Coronado. But I don't necessarily know. I guess if you're looking for a preparatory high school, I think I think Liberty might be one. I'm not entirely sure, but I'm not sure which ones are preparatory. I think some are like career oriented though. If you want to look into that, I think like the technical schools are all like career oriented. So I guess it's kind of a similar idea to like preparatory
I will address that. I'm a middle school teacher, so a lot of my students go to different high schools. And I think the most important thing, if you want to be successful like an Ivy League school, like Aaron or Sherry, the key is you have to want to learn on your own. If you wait for teachers to tell you and guide you and just follow directions, you're just always going to be a technician. You're never going to be a superstar. And Aaron, so like you said, you started coding on your own in junior and senior years, and I think that's what you have to have. And I think schools actually detract from that sometimes by having so much homework that you don't actually have time to explore. And exploration is like a huge thing. So I agree. ATEC, my son went to ATEC. He's working on his PhD at Scripps. I think you can be successful almost anywhere, but you have to make those choices yourself, not just do what teachers tell you. No one ever does what I tell them to do.
I agree with Mr. Hill. I think a lot of it is, I think if you really want to learn more and be successful, I think it doesn't really matter which school you go to. I think a lot of it is just is finding something you're passionate about and exploring it out of curiosity. So I wouldn't necessarily worry too much about like the high school you attend. I would just try, exploring on your own and learning things on your own. I think that like some of self-drive and self-learning is really important.
Thanks, Mr. Hill and Aaron.